We're going to take a look at many solutions and no solutions today, and how can you determine the number of solutions a problem has? Well, our first question is, do we always get one solution when we solve a problem? Well, not necessarily. So far we have, but in real life, there's sometimes more than one answer, or there is not an answer to anything else. So if the question is, are there other possibilities? Yes, there are. For example, there has been no cure for cancer yet. It is still a no solution problem, yet they are continuing trying to solve that problem. A many solution problem would be finding a job. You can find a job in a number of places. So there are many solutions to that problem. Now, in our textbook, we are very fortunate to have Dr. Berger. And if you look in our textbook, every place it says math on the spot, you'd be able to watch him do a video. It'll look something like this. He'll pop up in the corner and you can have the CC on or off, which is closed captioning, so you can actually read what he's saying. Our key objective. And besides seeing him up here and seeing him working it out live, you will notice on the right, it'll have it all step by step written out for you as well. So there's another way for you to view examples, not just through me. Now, what we're going to do is do those two examples that we watched in class on Go Math. We're going to actually, I'll do them here because I can't record that straight up. So let's take a look at this first example here. X plus 8x plus 4 equals 9x plus 4. So what we're going to do first is we're going to separate our sides, and we're going to take a look. We have three terms on the left, so x and 8x need to go together. So that's going to give us 9x. The 4 comes down, equals, and on the other side, just two terms, so 9x plus 4. Hopefully people are starting to notice that both sides look identical. Well, we need to get rid of the variables so that we can decide what is actually happening here. So since they're both positive 9x, if I was to remove 9x from both sides, because what we do to one side, we do to the other to keep it balanced, so we do want to keep it balanced there, we find out that we are left with just a 4 on the left, and on the right there's also 4. So we have 4 equals 4. This is called an identity because it is the same thing on both sides all the time. How would write as our answer, though, is one of the following. We would either write all real numbers, or we would write infinitely many solutions. This would be your proof for why you chose these answers. It is always important to have the proof, not just say that that's the answer just by looking at it. Here we have another problem. We have 4 times the quantity of y plus 5 equals y minus 10 plus 3y. Well, first what we're going to do is use the distributive property and distribute that 4 out to both items there, both terms. 4 times y is 4y, and 4 times 5 is 20. On the other side here, we have 3 terms, so we know that 2 terms need to go together. The y and the 3y need to go together. So what we're going to do is combine them, and we will get 4y minus 10. Now at this point, you're starting to say both sides look a little bit the same, but yet different. They both have 4 y's in it. So let's get rid of that 4y by doing the opposite. And that makes the y's go away, and then we're left with 20 equals negative 10. We know that not to be true, that is false. And since that's false, that's called a contradiction. What we would do, though, as proof, this would be our proof, and our answer then would be no solution. That's what we would write. You also, if you didn't want to write the word no solution, you could use a 0 with a line in it, which represents an empty set. That means there isn't anything possible that would work for this problem. So that's just something there to think about. Now realize, whether it was this problem or the one previously to it, we did not check our solution. We did not need to. We didn't need to because we had no variables at the end. Remember, you need to have a variable to plug back in to check. So we didn't have anything, so we did not need to check there. So let's recap this. We get one solution, and when we do, we end up with x equals y equals some variable equals a number, whether it is a whole number, an integer, a rational number, a fraction of sorts. It doesn't matter. That gives us one solution, and we're going to check our solution. We could get infinitely many solutions or all real numbers. That happens when the variables all disappear and both sides are equal to exactly the same number. For instance, here, 3 equals 3. And the last one would be no solution, or we would use the empty set symbol to represent that. And so when we lose all the variables when we're doing the work and we end up with 2 different numbers that are not equal to each other, please be cautious. These 2 down here only occur when you are solving the problem. I tend to see students when they're looking at the check and they get all caught up in this, and then all of a sudden they want to start writing this. Remember, this has to do with solving the problem, not with checking the problem. Hopefully this helps explain a little bit more about many solutions and no solution.